Thanks for listening. This is Brian Hurley from Business Performance Improvement. The podcast Lean Six Sigma Bursts are short lessons, comments, Q&A, and insights. If you have a question, send your question through the Anchor app, and we might feature you on a future episode. Or contact me at biz-pi.com. Quite a few years ago, back in 2013, it's called Top 3 Things to Validate Before Removing Test or Inspection Steps. So sometimes in our lean improvements, people will look at inspection and testing steps and try to figure out if there's a way we can reduce or eliminate them. And that's definitely a form of waste in general. However, you don't want to remove them if you still have the possibilities of those failures or defects coming through the process. So I provided some criteria that I look for before I would propose anyone remove those steps. So let me walk through the article with you and then let me know if you have any questions afterwards. A process with excellent capability usually means that there is a very small probability that the natural variation of the process will exceed the specification limits. And so this would be for a process where we are taking a measurement and they have some kind of specification limit. Without getting into a detailed discussion, let's assume you are calculating PPK for this process, which is a type of capability indice. We'll discuss CPK and PPK confusion at another time, but I got a link to a article that does a good job of explaining why we'll be using PPK for this discussion. And basically, the CPK is a short-term calculation using a moving range standard deviation, and PPK looks at the long-term variation using the traditional standard deviation formula. Formulas are the same, but how you calculate them are slightly different. PPK is usually more of a worst-case scenario. Most customers would like PPK to be 1.33 or greater, which is roughly about 4 sigma, where the probability of having a failure is less than 1%, over 99.3% basically. Even with this process shift of 1.5 standard deviations, which is typically used in some Six Sigma calculations. Whether that's a necessary adjustment or process shift, that's another discussion. If you improve the process even further, you might even achieve Six Sigma, which would be a success rate of 99.99966%. This also depends on your industry, as some lower volume industries might accept a lower PPK, while higher volume production may require PPK greater than 2.0, which would be over Six Sigma performance. When I worked in aerospace, we would usually set a little bit lower thresholds because of the volume that we did, which is much lower, sometimes only 1 or 2 units per day. For the purpose of this article, let's assume the process has been in place for some time, a full rate production levels or service levels, not a discussion during design and development of a new process or product. In addition, even if your process has 100% yield, does not mean it has good capability. Therefore, a pass-fail step should switch from attribute to variable data collection if possible, so PPK can eventually be calculated. At some point, the chance of having a failure is so small that the question comes up from management, why are we still testing or inspecting this characteristic if it is unlikely to fail? Can the test or inspection be eliminated completely? Can we reduce it from 100% down to maybe 50% or 25% or even 10%? From a lean perspective, inspection and test are non-value added but necessary, which are avoiding the problems from getting to the customer or further into the process. But perhaps these steps are not even necessary because the process is so good. In most cases, the end customer will have some say in this matter, especially if they provide the requirements to you. By default, they will be highly resistant to any test or inspection removals. It adds risk to their processes, and they usually don't see any benefit. Although there is benefit when you look at the time savings of the process and being able to get product or service to you faster. So given this resistance, what evidence is required to alleviate their concerns and allow approval of a reduction or elimination in a test or inspection step? We've not found any formal documentation on how to deal with the situation, but if someone has some guidance or from any industry, please let us know and we can share it with other clients. But here is my typical response when asked this question. There are 3 areas to look at to prove test or inspection reduction to a customer: stability, capability, and risk mitigation. For stability, looking for a consistent process data results with no outliers, no trends or shifts on the control chart that have been happening over a long period of time, which long can vary by industry. PPK calculations assume a stable process, so stability provides confidence that the calculation of PPK will be maintained in the future. This also implies a sufficient sample size has been obtained that clearly shows the underlying distribution of the data, such as a normal distribution or Weibull or log normal or skew data. Second one is capability. So good capability results of a PPK greater than 1.33 minimum typically, but preferably over 2.0, which would be more like the Six Sigma performance. PPK calculation is also based on any assumption of normality, so if that's not valid, then the PPK results may be slightly incorrect. And third is risk mitigation. Clear documentation of how the process will not produce defects, a shift, a trend away from the average, or increase in variation in the future. Typically, this involves evidence of mistake proofing, SPC knowledge, and a real strong adherence for operator and worker training. Even if there are some clearly defined processes for making this decision, an agreement between customer and supplier will always be required. We recommend you have this discussion as early as possible before preparing a package or presentation to make sure the customer will consider this option and the amount of evidence is agreed upon ahead of time. There may be very high severity characteristics, such as safety critical or operation critical, that will be difficult to justify for sampling, even with high PPK values, due to the severity of even one escape. An example. Let's look at a generic example to see how we can compare against the three criteria. Let's assume you have an inspection process that measures the gap between two parts. The gap is recorded into a database as measurable data, and the results are tracked on an individual's moving range chart, which is an SPC control chart. For stability, in the diagram in the image, you can see that there is no out-of-control conditions identified on either chart, so we feel confident that the process has been stable during the time period of this chart. So let's assume that this is a 6-month history of 100 data points. For capability, since we've already shown a stable process, we next check the normality of the data. The chart looks good in the view below with the normal probability plot, but technically it fails the normality test. However, this is due to the resolution of our data. If we could go one more decimal point down, the normality test passes. Therefore, our data is normally distributed. Next, we look at the capability histogram compared to the customer requirements and look at the PPK calculation. Clearly, the data falls well within the lower and upper specification or tolerance limits of 15 plus or minus 0.20. PPK is calculated at 2.40, which is better than a Six Sigma process. There would be a very remote chance of a failure due to random chance. Therefore, the process is considered capable. List of past defects and outliers, along with root cause corrective action that includes a mistake-proofing device implemented to prevent recurrence. Operator and engineering records on SPC training classes complete. SPC is statistical process control, in case I didn't define that. Documentation showing the operator enters data, reviews chart for out-of-control conditions, and takes action when required. An updated FMEA, which is a process failure modes and effects analysis, which is a risk mitigation tool, with a history of completed actions that reduce the highest RPN scores, the risk priority number scores, and regular meeting minutes showing updates to the FMEA using a cross-functional team. History of SPC charts on this process to prove that the SPC charts are not brand new and that the common and special cause variation has been improved over time. Operator training program to show how new employees are properly trained and supervised with regular oversight until skill competency is proven. Good documentation and work instructions on the process, mainly the pictures, clear explanations, cautions or warnings, color coding, etc., to give confidence that a new operator would not produce defects. Key parameters that have been flowed to the supplier to help control variation of this particular measurement. And a history of a stable supply chain, no recent supplier changes or disruptions. Some others may require less than that. However, the more you can complete and provide with your proposal, the higher the probability it will be approved. Want to improve the chances even more? Show the customer what cost savings you can provide to them by reducing or eliminating the inspection or testing step. Most likely, the first request for elimination of these steps will be rejected by your customer, but hopefully they will agree to a reduced sampling plan, such as checking every other part instead of every one. After a few months of success, maybe every 4th or 10th part will be checked, until eventually the test or inspection is completely eliminated. So in conclusion, without any clear industry documentation or guidance on how to reduce or eliminate inspection or test in your process, we hope this provides you with a starting point to see if your process is eligible or not. The more evidence you can share with your customer regarding stability, capability, and risk mitigation will increase the chance that they will agree to reduction or elimination of a test or inspection step. Giving the customer a financial incentive to approve doesn't hurt either. So what are your experiences with this? Have you had success doing this? Does your customer refuse to accept any type of evidence? And then risk mitigation. Now that we have capable and stable performance, we still need to give the customer confidence that we can maintain this performance into the future. We recommend including the following information in your discussions and proposal. So again, this is really geared around taking measurable data and having specification limits and showing capability. If you don't have a process that has measurable data and you just have pass-fail results, you're going to need a lot more evidence and data. There is a way to do a sigma performance level using the failure rate, but you're going to have to be up in that high 99 percentile range for you to be able to justify to the customer that it's not needed and you're not finding any problems. So I think you'll have a better luck of just going to some kind of a sampling method and then being able to show how you're going to quarantine if you do find a defect. So you could check, okay, we checked it every 10th. Now we're going to be able to get our hands around those 10 from the last time we checked to until now. So there should be 10 or so that are maybe need to be retested and rechecked. But it does get a little more tricky when you're dealing with just pass-fail results because it's not as accurate in the numbers, and you'll have much more larger sample size you will need to be able to show the confidence to the customer. So if you have a high volume process that has really, really high success rate, then you've got a chance. So again, hope this helps. I'll have a link to the article in the show notes for this episode. And if you have any questions around that, please feel free to reach out. Thanks. Lean6SigmaDefinition.com has a list of glossary items about popular process improvement terms, along with the history of Lean and Six Sigma methods, and key influencers like Dr. Edward Stemming, Henry Ford, Taiichi Ohno, Shigeo Shingo, and many more. You can also learn how to access affordable Lean and Six Sigma training and certification. Visit Lean6SigmaDefinition.com.